Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today, we have learned the subject on W3601 Protection and Switchgear for 2021 regulations. In this presentation, we have discussed the topic on protection of transformers. This topic explains how transformers are protected from internal faults, and the transformers are costly and critical equipment in power systems. So the proper protection helps avoid damage and ensures continuous operations. So the differential protection scheme are used for this safety. Then differential protection scheme. So the differential protection is used to detect the internal faults in the transformers. So it compares the input and output currents of the transformers. So if both currents are equal means the transformer is normal. Otherwise, any difference indications in indicates a fault and trips the systems. Next, biased differential protection scheme. So this is a circuit diagram of biased differential protections. So in this method, CTs are used on both primary and secondary sides. So it improves stability and avoids false tripping. So biasing helps to handle errors due to external faults. So it is widely used for reliable protections. So differential relay act is now inactive in normal operation. So active in fault conditions. These are the star delta spray production of differential protection schemes. So it IP represents the transformer's primary rated current. IS denotes the transformer secondary current. The current transformer on the primary has a say ratio of IP to 1 amps. On the secondary side, the CT ratio is IS to 1 amps. This setup is used in bias differential protection schemes. So next, construction details. So the current transformer secondary windings are connected in a oppositions. I mean are linked so that the secondary currents flows in opposition to each other. So under normal conditions, the currents cancel each other. So fault current is equal to zero. So there is normal operations. So no current flows through the relay. So the relay is inactive. This ensures stable operation without unnecessary tripping. Operation. So, operation of a differential scheme, when an internal fault occurs, current becomes unequal. So, this creates a differential current in the relay. So, the relay operates and sends a trip signal to the circuit breakers. So, the circuit breakers disconnect the transformer. So, we have to protect the transformers. Then limitations of differential protections. So current transformers errors and saturation can affect the accuracy of the system. Then magnetizing ingress current may cause false operations. uh, Next, limitations of differential protection is long pilot wires introduce a resistance imbalance, and proper settings are required to avoid maloperations. So these are the limitations of the differential protections in the transformer. Then tap changing, another limitations on the tap changing in transformer affects current values. So this may lead to incorrect relay operations. So high settings reduce sensitivity to small faults. So careful calibration is necessary in this system, in this scheme. Then protection against incipient faults. So incipient faults are small faults that grow slowly. So they are difficult to detect in early stages. So the special protection like Buckel's relay is used for this unavoid mal operations. So early detection helps prevent major failures. Then Buckel's relay. So Buckel's relay, it is a gas operated relay used in oil transformers. and it detects faults by sensing gas formations. So gas is produced due to insulation failure. It gives an alarm to a trip signal. So the trip circuit breakers disconnect the circuits. Then operation of Buchholz relay. So this is the block diagrams of the Buchholz relay in the power transformers. So here conservators, Buchholz relay, transformers main tank, and strip circuits, mercury switches. These are the components of this Buchholz relay. So how to operate it means the relay is placed in between the tank and conservator. So the gas accumulation or oil flow activates the relay. It works with a slight time delay and it provides both alarm and trip functions. So the relay has a float mechanism to detect the oil level. So if oil level drops, contacts get activated. So it gives an alarm signal to the operator. So this helps to prevent the serious damage. Next, restricted earth fault protections. So this protection detects earth faults inside the transformer. So it is more sensitive than differential protections. So it uses CTs and a neural network transformers, and it also useful for low fault current conditions. Working of REF protections. So CT outputs form all phases are connected together. So they are linked with a neutral CT. So any imbalance indicates on earth fault. So the relay trips the transformers. Relay trip to the send a signal to the circuit breaker, and the circuit breaker trips the circuits. That we have to protect the transformers. Then overcurrent protections. So this protection works when the current exceeds the limit. So it uses on overcurrent relay with a current coil. So normal current will not operate the relay. Then a high fault current activates and the trip the signal, send the signal to the trip circuits. So the circuit breaker disconnect the circuits. So we have to protect it. So advantages: protection prevents major damage to the transformers. So like quickly isolates faults like winding failure, insulation breakdown, etc. And it improves systems reliability and safety. So it ensures continuous power supply with minimum interruptions. And then fast operation reduces power interruptions. So protective relay act instantly during the faults, and it also improves system safety. So protects equipment and personnel from hazards, and it also reduces repair cost and ensures selectivity. Only the faulty section is disconnected only. Disadvantages: the protection schemes are costly and complex, so they require a skilled operation and maintenance. So incorrect settings may cause false tripping. So the regular testing is necessary for accuracy. Applications. So it is used in power transformers in generating stations, and it is also applied in substations and distribution systems. It also used in industries and transmission networks. It is important for renewable energy systems, for solar and wind plants. This presentation is based on standard textbooks. So books by Ravindranath, Paitankar, and Batri Ram are used. These provide detailed knowledge on protection schemes. So they are reliable academic sources. Thank you.